Alrighty, we are live. So today we're going to be doing some Quest Pro with Unreal Engine 5. This is part of a series that we've been doing. Just to kind of do a quick summary of how we're running this. So we went ahead and there's a fork of the Unreal Engine editor that Facebook maintains for VR, this one. This fork has a branch on it called Oculus 5.0. 5.0 for the Unreal Engine 5. We go ahead, we have a kind of a GitHub for Windows. Go ahead, we get the latest version of that branch. We open that up with Visual Studio. Visual Studio has build tools, and you have a .sln file, solution file. You have the editor here, UE5. You have to build that. Once you build that, you go to Development Editor, Windows 64, UE5, run it, and you'll get the Unreal Editor. So what we have open here in the Unreal Editor is the inside this Unreal Engine there's a couple samples. And there's different samples. We were previously in the week we were looking at pass-through sample, and today we're going to be looking at some hand tracking. So it's my cat yowling in the background. So specifically the one we have open here is hand sample. So we open it up. There seems to be some stuff here in the scene. We can build. So build for specifically our Quest Pro with the IP address there. And our Quest Pro is connected via the Meta Developer Hub, or MetaQuest Developer Hub, I think it's called. And you can set it up so it connects to your headset and use this Android debugger ADB over Wi-Fi so that you don't have to plug in your headset when you're debugging. And yeah, we have the casted. So this is our home environment, and we can see our controllers here. Let's make it bigger. So we went ahead and built this. We can platforms build for the Quest Pro, and we can actually go to the output log here, and we'll be able to see the output here. And when it's ready, it'll just deploy it to the headset. So if we go into this scene, we hit Control Space, that'll open up the content drawer. We have some different content here. We have models. This is a little bit outdated. These are old Oculus controllers, old Oculus Touch controllers. We have some hands. and then some kind of basic hand animations such as touching, pointing, holding. There we go, it's deploying on the headset. We have the skeleton for the hand. We have starter content, the UI itself. We have some blueprint classes, hand tooltip, custom hand tracking tooltip. If we open them, I can't really see anything. There doesn't see, it says it's a blueprint, but there's nothing in this graph. Event begin play, event actor overlap, widget, default scene root. There's some events that you can change here. We're also getting a lighting needs to be rebuilt, one unbuilt object. So maybe we change the light to movable. Okay, one unbuilt, so that wasn't that light. What about this atmospheric fog? Static, movable. Okay, so it was the atmospheric fog that was complaining about not being built. So let's get into our headset and see what we can get from the scene. Alright. So in the scene we have a floor, we have our hands. Okay, we can see it. We have, you can see that when we move, we can also hit this and we get the controllers. So this is how you know this is an outdated scene, right? You can see the button presses, which is good. But these are old controllers. These are all the different poses, so. Alright, so now the question is, can we actually do something with this? What if we, there's nothing to grab, nothing to spawn. So I think we just loaded an outdated scene is unfortunately the reality here. So let's go ahead and put these back, put the controllers back, and we're going to stop from our MetaQuest Developer Hub, and it'll send us back to the home screen. So yeah, unfortunately I think we just loaded the wrong one, so we're going to have to load a different project here. So let's close out of this one. Sure, we can save. And let's relaunch our editor, or our custom editor provided to us by Meta. So I'm thinking hand pose showcase, or hand train sample, or hand Oculus input test. Let's see if we can sneak in here, see what's going on. So gamepad, left center, hand tracking, HMD, mouse, BP, motion controller, touchpad. Okay, so Oculus input. This one was also updated more recently, right? 15 days ago, 15 days ago, 15 days ago. I really want to try the spatial anchors. I'm curious what this is. Spatial anchors, blueprints. Spatial anchor model, BP spawn, save game components. Okay, so the Unreal Engine has started. Where is it? There it is. Loading. Okay, I think we're going to do this one, the Oculus input test. I think these other ones are old. Right, let's look at the history here. June 16th, October 3rd, October 20th. Okay, so the way we get to these is you have to hit the browse and then go to the Unreal Engine branch, and then inside that samples, and then Oculus. And let's try Oculus input test. Let's see what this one looks like. Oculus input test, Unreal Engine project file. This project was made with a different version. Okay, let's not do that. Let's try a different one here. What about hand pose showcase? Does this have plugins, documentation, source, hand pose showcase? Okay, so this is a C++ project. Base. Nope. Base.h. Generated body. CPP. I feel like there's nothing in here. Force throw, slide. This still looks old. Oh, okay, wait, this is interesting. This is this is definitely an old version of Oculus though. What about hands train sample? Hands active, props, scene setup, track segment, tools, train cars, cow car, box car, hands train sample. What is that? Okay, so this is an older demo 2 years ago. This is probably the train. Okay, that's garbage. We don't really want that. What about spatial anchors? Actually, that kind of seems like the cooler one. Let's try spatial anchors. Damn, all of these were made with different versions. About hand pose. Okay, hand pose was made with UE5. It's good. It's good. We're making progress here. Okay, so here's our untitled editor world. Deprecated CVAR. Maybe we can see it. There's nothing in here. Interesting. This seems to just be completely empty. Open level. There's no level in this project hand pose showcase. Oh no, now we gotta restart Unreal Engine here. Boundary sample. portals, distance, field baked shadows, content. Okay. Scene. Hand train sample. Let's see what has changed. View this commit detail. So this was the commit that updated it. Wonder what's going on. You just deleted a bunch of stuff. Okay. Let's go to dev, Unreal Engine, samples, starter content, nope. Samples, Oculus, hand train sample, open, hand train sample, open. Okay. Would you like to rebuild them? Yes. Okay, so it actually seemed like the hand pose example just died on us. Has exited with code 0. Engine modules are out of date. Damn, okay. Maybe we can't do the hand pose. It's my cat. I'm drinking some espresso again. Okay. So let's try the input test. It's going to get rebuilt for Oculus 5 or Unreal 5. I think it's an Unreal 4 demo, so it might not be what we want. Adding movement sample. Who's this? Connor Hollis Meta. And you have this other guy, DJ Ethernet. Okay. Movement sample was added to Oculus VR 4.27. So this is still the old Unreal Engine 4. Which is interesting. It means you got people adding samples to the Unreal Engine 4 examples, right? kind of annoying. I feel like they should just move to Unreal Engine 5. Unreal Engine C++ API reference, cool. UE5 main. This is the actual Unreal Engine 5 branch from Unreal. This is the Oculus version of it. This is all the different C++ classes that you have available in Unreal Engine. What is Apple Vision? Apple Vision Async. F Apple Vision. Availability. Detected face. What is this? Kind of curious. Alright, this is still compiling shaders because it's updating the example. I wonder if we can run things on our Quest while Unreal Engine is not there, because it does kind of show this, right? It does kind of seem like the apps themselves are on the device. So maybe if we, for example, this is the pass-through sample we were playing with before. What if we like launch this? Yeah, so here's our work from yesterday, right, with the 3 different balls of different materials. Okay, let's see if we actually have hands in this scene. Okay, these are Quest 2 controllers, so this is maybe more updated. I wonder if it allows for hands. No, it does not. Okay, actually you can move around here. So there is movement. And I think you can... Right, this is the little movement widget. This controller is off. Cool. So you can run a different app while you let's stop, hit the stop. Okay, that stopped it. What if we hit it again? What if we hit stop? Stop casting. Cast. We might have to quit through the application itself. Let's see if we can actually hit it. Okay. We had to quit through the application, which is kind of weird. These aren't updated. It's restart. Okay. Let's go back, reopen it. Okay. Cast. This is still compiling shaders. Damn, this is gonna take forever. I wonder, so we're gonna do something here. In these samples, right, the two that we've gotten working. What about pixel streaming? Web servers? Meh. Oculus. We've gotten the pass-through sample to work, right? And then there's a bunch of content. VR template, blueprints, grab component, menu, grab type, VR pawn, VR game mode, teleport. Audio. Okay, really the pass-through sample seems to actually have the most stuff in it. If only we could get this to work. This might actually already be dead. Okay, we're going to rebuild and go into the pass-through sample. Relaunch the editor and go to the pass-through sample and then see if we can add controllers there. Can you import components from other projects UE5? I wonder if the VR starter project works. We haven't tried it, so. Okay, so I mean, it seems like it's working fine here. Let's see if we can actually see it. Launch the game on Quest Pro. I think we tried, but then it failed. Is that what happened? I don't exactly remember. SDK verified. Okay. And now it's building the executable, which might itself take some time. While that's doing things, let's actually look at the stuff in here. Okay, so these are grabbable mesh. Got pistols, sky sphere. Where's the main actor? Fire queue. Nav mesh bounds, text render actor, player start. Yeah, look at this. Clang. This is going to take hours here. 4 out of 834. Collision capsule. Content. VR template. Haptics. Grab haptic effect. Amplitude and frequency, so I guess this is the frequency and amplitude of the haptic when you grab something. Right, so this axis here is probably time, and then this is the magnitude of it, so it's like a for 0.01 second. Maybe if we compare that to the pistol haptic. Yeah, it's a little longer, so it's not 0.01 seconds, it's like 0.10. And the frequency seems like it's the same. I don't know what this is. Okay. I was hitting space there. Maybe it, like in some of those keyframe animation editors, spaces play. Blueprints. Let's look at these blueprints. Grabbable small cube, grab component, menu, pistol, VR game mode, VR interaction, BPI. Let's look at grab component. What does that look like? Event, begin play. Blueprint, implementable event for when the component is beginning play. Called before its owning actors begin play. Or when the component is dynamically created if the actor has already begun play. Target is actor component. Okay, so there's a Boolean is held. These are different variables within here. This is a function. Set should simulate on drop. That's what happens here at the very beginning. So the execution, once you have once you start this actor, this grab component actor, I don't know what this is. Ooh, look at that. Try grab, try release, attach parent to motion controller, set should simulate on drop, and then event grab. So that's kind of cool. I wonder if there's a way to know what object this is attached to. Right? The grab component, parent class, scene component. Grab component, snap. Grab component. Okay, so the grab component is not a property of the controller or the kind of like the player. It's a property of the actual object that you want to be grabbable. Okay. Grab component. Edit grab component. Okay, and then here you go. Okay. So actually, if we wanted to, let's try to see if we can make a grabbable something else. Let's come here in this scene. This is still building, by the way. We see here 53 out of 134. We might not even get to it until the very end of today. So let's go ahead and add a basic shape. Let's add a cone. So bring it up. Up to here. Let's put it right there. Just make it a little bit smaller. Let's do 0.2, 0.2, 0.2. Alright, and we're going to try to copy some of the properties from this cube, for example. So this cube here, you have a mesh. Okay, so cone. We're going to call this grab cone. Okay, and it has a mesh component. So the cube is it's an actor. It's a okay. So we actually need to add actor. Child actor. No, we need to add a plus actor. This actor here, this is what we're going to call it grab actor cone. Alright, then we're going to see if we can add our grab cone to it. So can we put our cannot attach static actor grab cone to dynamic actor grab actor cone. So grab actor cone is static. If we make it movable, can we now put it inside here? Inside grab actor cone. Okay, so now if we go to grab actor cone, no, it's underneath it, but it's not. Okay. I think we just need to delete that. So we need to add it in here. So add a static mesh. Let's call this cone. Okay, so the problem is that this is not. Maybe we need to add a cone or something like that. Yeah, basic shape cone. Okay, there we go. So let's go ahead and delete all this crap here. Yep, grab actor static mesh. That's what one of these squares looks like, and we're trying to recreate that here. So it cannot be copied, renamed, or deleted. It can be replaced by drag dropping another scene component over it. Okay, so we're going to add our cone. Alright, let's just call it. Another thing called cone already exists. Call it big cone. Okay. Grab actor cone. We're going to bring this up. Okay, so big cone. We're going to make this movable. Let's see what else. This square here, there's a mesh that's movable. Has some material. Simulate physics. 0.01 linear damping, 0.00 enable gravity. So let's go back to our cone. Go to big cone. Simulate physics. Yep, same linear damping, same gravity. I think if we go here, there is a small amount of mass. Collision, generate overlaps events. Character step up on collision presets. Okay. Grab actor cone in big cone. Collision. Generate overlap events. Yes. Collision presets physics actor. Okay, perfect. That's the same as this. Okay, so now grab actor cone. We need to add a grab component to the big cone. So we're going to add a grab component. And what do they call it? They just call it grab component. So we're going to call this grab component. Okay. And I wish there was a way to compare outliner UE5 outliner compared to two outliner windows. Control Alt for more. Okay. Alright, let's see. Let's see what we have here. We have in this cube, we have our grab component, movable, grab type free, visible. Let's see. Grab actor cone. Grab component, we got movable, grab type free. Okay, that's all the same. Rendering, cooking, physics. Okay, let's see if that's different to any of the things here. Use attach parent, physics, free. Okay. Okay, so that's all the same. So hopefully this should just work fine. But why don't we give our big cone material here? Ooh, look at this. We got some brick materials. Let's do brick, clay, old. Okay, it has to prepare a bunch of shaders for that. Go ahead and save this. Alright, let's go back to the blueprint editor. Back to our grabbable cone. Big cone, grab component. Let's edit the grab component. Let's go deeper in here, make sure. See if we understand what's going on there. It's still building slowly. Let's put our headset to charge here and plug it in. Okay, we're not able to why can't we hit this button here to edit in Blueprint? get to it through here. Grab component blueprint class. Yeah, okay, we double click on that, somehow it works. Okay. Let's go back. So there's a bunch of different functions here. The event graph, as far as I understand, is like the main one. Ooh. I guess you can reposition them. And then you have macros. What is a macro? A macro graph allows you to encapsulate functionality and reuse it. Macros have a single input and output node, but you can add as many input and output pins as you like. Macro can contain nodes that take time, but cannot contain timeline or event nodes. You can add local variable nodes to a macro, and their value will persist when the macro is complete. So you have motion controller, target, read the value of a variable motion source. Okay. Output hands. Get hand from motion source. Okay, so it's actually color coded. Object types. This is a single variable. This is called hand. And then you have motion controller, which is a motion controller component. Okay, attach parent to motion controller. So you have a function here, get attach parent. Get the scene component we are attached to. Okay, so we have some target and we have our motion controller. This attaches one thing to another thing. There's this thing here called weld, so if you have physics, it'll weld both of them together, so the physics is shared. Branch statement, if condition is true, execution goes to true, otherwise it goes to false. So the condition is return value. Okay, so if you get true, that means the condition was true, or the attach was successful, and then you're going to go up top here, and that's it. Okay, if the condition is false, that means the attach wasn't successful between the motion controller and the attach parent, and you're going to try to do the same thing here. So you're going to use the same get attach parent, except now you're going to get the display name of the object, or actor, I guess, and the display name of the motion controller actor, and concatenate strings, and then you're going to basically create this debug string here that is attaching attach parent to the motion controller failed, and it returns a string which gets printed and outputs. Okay. All right, I think we kind of understand what that is. Get hand from motion source. All right, and now we have a bunch of functions here. All right, these functions are try grab, try release, trigger press, trigger release, trigger axis, should simulate on drop, sev, set, primitive comp physics. So let's try grab here. So first thing you do in try grab is you have your motion controller. What is this try grab component? Okay, so actually these are, I think these purple ones here are the beginning and end of the function. So this is one end, this is another end, and then these are parts of the function here. Okay. So if we go to try release, we have two possible return nodes, and then the original one, trigger is pressed. Here's the original, there's no end. Trigger released. Yeah, I don't. So what happens here, right? Trigger released, advanced. Get owner. This just doesn't even seem completed. Trigger axis also does not seem completed. This one does not have a return either. Set should simulate on drop, so this is kind of where it starts. You get the parent target is scene component, self. That becomes the object. Get attach parent, get the scene component we are attached to. There's a lot of get attach parents here that are kind of confusing. Where is this at? 270 out of 834. Okay. Cast to primitive component. As primitive component. What is a primitive component? UE5 primitive component. This is old documentation. Components are a special type of object that actors can attach themselves to as subjects. Oh, no, that actors can attach to themselves as sub-objects. Components are useful for sharing common behaviors, such as the ability to display visual representation, play sounds. What the hell is going on here? Oh, this is the old, huh. So we actually have two instances of the Unreal Editor running. This was the one that we were compiling the shaders and it just never worked. We don't want to use this though. Let's close out of this. Okay, these are all the different motion controller statuses. That's weird. It was running in the background this whole time. Maybe this will make Clang speed up the build. Just because it's not running that. Let's go back to our... They can also represent project-specific concepts, such as the way a vehicle interprets input and changes to its own velocity and orientation. Okay. But we still didn't learn what a primitive component is. Okay, here we go. Primitive components are scene components that contain or generate some sort of geometry, generally for rendering or collision purposes. Most box, capsule, static mesh, skeletal mesh. Okay. So this gets the scene component that we're attached to with this grab. So this grab blueprint, right, is on the cone. So when we say get attached parent, we're going to get this big cone mesh, right? When we cast it to a primitive component, I think we just get the mesh. Okay. And then with that mesh, we in collision profile name, update overlap, set collision profile name. I feel like nothing happens here. Oh no, it goes into the set collision profile name. This will change current collision profile name to be this and overwrite collision settings. Okay, we have a similar kind of casting to a primitive component here. And we actually have the output if it actually fails too. So this is the... If it succeeds, then we're basically saying simulate Boolean. What is that? B simulate. Okay, grab type. Okay, there's different types of grabs there. And I wonder if we can like see find references. Oh, okay, that's kind of cool. This is very useful. I can get the references of this grab type variable. It's used here in the try grab function, where you have a switch statement here, and depending on the grab type, whether it's free, snap, or custom, you're going to do different things. Okay. It's also used in try release, which is a different function here, and also it's used to condition a switch statement, which then does different things. So free and snap have the same, end up doing the same thing. Yeah, so whenever you're grabbing something, the distinction between free and snap matters, right? It's basically, are you like free grabbing, I think, is you can grab it wherever. Snap grabbing is you go to grab it and it'll just it'll snap the center. So we look at the difference here between them. So far they're basically the same. Motion controller, target, self, simulate. The difference is here. Orient the held actor to match the grab component's relative location. I wonder why they have these parts that are the same, right? Couldn't you maybe get rid of this, put the switch statement after this, and then just either have nothing or this? Something to think about there. Okay, orient the held actor to match the grab component's relative location. So this is the kind of snapping. You get the attached parent, the relative rotation, variable type rotator, primary grab relative rotation. Okay. Rotation of the component relative to its parent. Invert rotator. Negate a rotator. Okay, so the opposite of the rotation. So you get the relative rotation. Let's see what else uses this. Let's go here, find references. No results found. That's wrong. There's one right here. Grab component and motion controller. An on-grab haptic effect. What did that do? It doesn't do anything. Okay. Event dispatchers, on-grabbed, on-dropped. I wonder if there's like references for that. Find references. On-dropped happens here. When you try release, you call on-dropped. This can be used for custom grab release logic. Okay, we have another branch here, and then we have a is-held boolean, and depending on whether the is-held boolean is true, you either say we have not been released or we have been released. So here you're returning a boolean. This is held, again, also being modified in the try grab, in the try release. Okay, so here this is interesting. You have the variable is held, and then you have a return node that returns the is held. I wonder, like, couldn't you just set the isHeld property? Why do you need to return it? Right? Like, why can't you do this? Set isHeld. Maybe you just don't want to explicitly set it if it's false. You only want to set it if it's true. Executes a series of pins in order. Okay, so it is happening. First you're doing... Sorry about that. 1 second, let me blow my nose. Okay. So when this try grab function starts, it's going to do two things in a sequence. First, it's going to, depending on the grab type, it's going to go into this switch statement. It's going to try to use this attach parent to motion controller macro, and it's going to set the isHeld variable if that's if that ends up successful. On attachment failed, which is one of the possible outputs, I think, of this. Yeah, outputs attachment failed. So I don't know if you can, like, yeah, so you can output specific ones here. So back to our try grab. Yep. So if that attachment fails, we don't have anything for that, but if it does not fail, then we have we set the isHeld boolean. If it's free grab, that's basically where it ends. You set the isHeld boolean, and then you go back here and you do this second part of the sequence, and you say, you ask isHeld true, right? If it is true, then store a reference to the motion controller that initiated the grab. Okay, so motion controller ref. So a reference to the motion controller. What do we need that for? Call the event dispatcher so that we can do custom logic in the blueprint that implements this grab component. Call on grabbed. Okay, so that's what this is. Okay. So the on grabbed, right, is this event. Maybe think of it like a callback. And then we want to have a reference to the motion controller object. So that's probably why we set it here. We set this variable called motion controller ref, so that whenever we do, we kind of go into our on grabbed callback or event dispatcher, as it's called here. We'll have a reference to that if we want to use it. But it actually seems like we use it here as well. So we call on grab, then we play a haptic effect. The target for the haptic effect is getPlayerController, which is another function. Can I go to definition? this might not be a blueprint. This might be a built-in function or something. We have a onGrab haptic effect, which is a, what is this, a reference? Yeah, object reference. Okay, so we have a reference to the haptic effect object that we want, and hand, controller hand to play the effect on. Get hand from motion source. Okay, so hand enum, hand this is get hand from motion source. This is also so you have a motion controller reference that we're giving it. Read the value of variable motion source from the target. Okay, so we have motion source. And then returns true if A and B are equal. So there's a property of the motion controller object reference called motion source, and if that motion source is equal to the left hand, then we're going to say left as we're going to return left for the hand. If it's not, we're going to say right. It seems kind of convoluted. I wonder if you could have just done this without that. Like, why do you need to do this as a macro? But anyways, you get the hand left or right, which is, it's an enum, right? So 0 or 1, which is going to be left or right. onGrab haptic effect, get player controller, and then we're going to return is held true. Let's actually see where our build process is. We're almost there. 648 out of 834. Okay, I'm going to blow my nose real quick again, but let me first take a little sip of this coffee. Okay, we're back. So I think one question I have after going over this is, when do we use macros and when do we use functions? UE5, when to use macros versus functions. Here we go. 2014, blueprint macros and blueprint functions. Over and over from other places. A function does not support calling latent nodes like delay. Okay. Functions only have one input and one output. A macro is compiled as if you inserted all of its nodes directly into your blueprint. That also means that if you don't use your macro, nothing will be compiled. So the macro doesn't get built. It runs every time. I don't know, I don't really understand this analogy here. Represents a single unit that is compiled once and can be called over and over. Does not support latent nodes. What the hell is a latent node? Okay, create a latent node which will tick a few times depending on our input. BP async node. Okay, so I think latent just means time. Okay. Multiple inputs and outputs. Let's say you have a function called getCircleCircumference, like so. GetCircleCircumference, radius of 2, multiply by pi, and then return. Okay, and your event graph looks like getCircleCircumference, like over and over and over again. When you compile, your function is compiled to a single unit, one single factory, and your event graph tells a single function to calculate the circumference of a circle 5 times. Okay. However, if you instead use a macro defined like so, and much like before, your event graph used to calculate the circle circumference 5 times, so you have the same thing, but now it's a macro. You have much the same behavior, but instead of having one single compiled unit you call over and over, all references to the macro are replaced by the contents of the macro, and thus what is actually compiled is this. Macros are a series of functions or a bunch of instructions tied together to activate an outcome or shortcut quicker. A function does, well, a function one particular thing, like the function of a toothbrush is to brush teeth. Macro is a collection of regular blueprint nodes that you can use easier than reinventing the wheel every time. But a function is very similar but still very different. Cool. Let's see if this is done. Oh, we're tantalizingly close here. 802 out of 834. Our headset kind of died. Let's stop casting and hit cast again. Okay, we need to... allow. Oh no. Oh, we need to unconnect it. Hopefully we didn't just kill it. I accidentally hit deny when it said let device access. So and to answer the earlier question, I was correct here that you could just literally put this in here, right? And that's basically what a macro is. It's like imagine that this is just expanded in this point here. So yeah, if it's really only used once, it seems overkill to make it a macro. If it was used in multiple places, it would be worth it, but try release, it's not used. Okay. Looks like we're finally deploying this onto the Quest Pro. It should be popping up relatively soon here. Let's see if we added it to here. Ugh. It's having some issues here. Hopefully it's not these permission issues. Build successful. 59 actionable tasks. Performing streamed installs. Success. There we go. Hand sample, PT sample, OVR monitor, and com Epic Games My Project. Okay. Let's deploy directly to device. I think that allows us to not have to hit this launch button. If we hit that launch button, what happens? Alright. We are launching. It is loading. Let's look at our performance manager. Can't see anything. Is this even? Yep, this is still good. Device manager, maybe we look at the logs. Where was the logs against device logs? Here we go. Error, cam, personal dick, latency, potential track to map, images too dark. Okay, just a bunch of crap here. Face tracking data not populated. Okay, nothing useful in there. Let's hit cancel on that. And yeah, came back to that. Let's go ahead and launch this again. See if this time it works. Nope. It fails. Let's unplug it and hit launch. Fails. Let's see if we go on the Quest Pro, grab component. What did we change? Save selected, sure. We hit the deployed directly, so it should just pop up on here. Go, go, go! Okay, we have... Is there any errors that came up here? Warning. Capsule is not initialized properly. Okay. So put word wrapping on so we can see what's going on. Okay. It keeps airing out. So what's going on here? Confine package resonance audio. Okay, so can we just delete the audio? Search audio. Great. No matching actors. There's nothing that uses the term audio. What about resonance audio? Can we search it on the content drawer? Search in all. Can we disable Oculus resonance audio? Getting started, Unreal. Open settings, select project settings, scroll down to plugins, resonance audio. Edit project settings. Plugins, resonance audio. Resonance submix default. Binaural high quality. Can we just delete that? Maybe that'll allow us to do that. We're going to hit save. And let's see if we can put it on there. Ugh. Maybe this just resonance audio dependency isn't updated for the Unreal Engine 5, so I'm hoping that if we delete that from the project settings, maybe it won't bother to load the audio and we won't fail on that. But there might be a failure later, so maybe it's a moot point. Okay. Failed to load resonance reverb submix from resonance settings. Resonance audio built-in. Built-in other. Built-in reverb. Let's do built-in reverb. Okay, so we're getting rid of this resonance audio. And now let's try to put it on there. The joys of game development. Lots of building and sitting and waiting around for things. Okay, well, we got rid of the resonance audio error, but now we're getting this. Okay, assertion failed, adder, get data, source runtime, core containers array.h. Attempting to use a container element, okay, some reference, which already comes from the container being modified. What the hell is this? File C blah 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 array H line 1527. Let's open VS Code. Let's open that file. And let's go to line 1527. Checks that the specified adder address is not part of an element within the container, used for implementations to check that reference arguments aren't going to be invalidated by possible reallocation. Okay, I mean, this is pretty low level. This is like literally the array implementation that is being used here. We were close, guys. We were close. What if we take our grab actor cone? What was we were talking about like exporting? So content, blueprints. Grab component, grabbable small cube. Migrate. Okay. And let's see if we can migrate this into the one that we have working, which is the Unreal Engine, samples, Oculus, pass-through sample. What do we need to choose here? Content? Yes. Okay, so we migrated the content. Let's close out of that. Let's open project. Let's browse to the Unreal Engine, samples, Oculus, pass-through sample, PT samples. Because we know that one works. Let's go ahead and run this. hell does that mean? Okay, so far we haven't touched anything, so hopefully it should work. Okay, we're in Unreal. Okay, and we have the pass-through. Okay. Good, the project still works. Now, let's see if we migrated the components. So, no, we want PT sample inside VR template. Inside blueprints, I suppose, and then grabbable small cube. Okay, bring it into this world here and put it right there. We have our grabbable small cube, grab component, static mesh, blah blah blah. And then our player start. Okay, so all we did was just drag the cube onto the scene. Let's see if now when we build this, what happens. Okay, processing assets. Little warnings there. Capsules not initialized. Okay, it doesn't like the player capsule. I think that's what it is. Couple more warnings here. Oculus XR capsule collider. So there's like some, I think that's what the, here in player start, there's the collision capsule for the player. Enable word wrapping. Okay, we're live. And do we see the cube? There it is. There's our little cube. Okay, we have a resume. Let's see if I can grab it. Damn, it's too far away, guys. I can't actually even grab it. to move it much closer to the player. All right, let's hit cancel here. Let's go back to our scene, and we will go ahead and move this little square. Let's do top. Let's move it right here. Let's do left. Let's make it much more even. And let's go ahead and make this mesh significantly larger. Let's do 1.0, 1.0, and 1.0. Okay. So now we have a, let's go back to perspective. Now we have a much bigger cube. Let's hit F to focus. And it's right in front of the camera and the player start, so we should be able to grab it. So let's go ahead, hit save, and let's run it again. Deploying. All right. Back in our headset. The cube is here. Going to go ahead. That's way too low still. And also, we just don't even have, like, we can't even do anything with these controllers. There's no button pressing. Let's take this off. And cancel again. Let's do a right perspective, and let's move this way up here. Save. And deploy. AI controller. VRPT pawn, player start. Maybe if we go to grab component, edit in blueprint. So we don't really have any of the stuff that we saw in the previous one here. Is this even the same? So content, let's open this up. Yeah, that still has all of our stuff on it. Okay, let's see if here we have the... Let's see if we can find the cube here. ¿Dónde está cube? Can't even see it. Is it too high? It's just not even here. I wonder if we move over here, can we see it? No. Alright. We have no idea where this cube is. I feel like this stream is already a little bit too long, so maybe summarizing kind of what we did, we tried to get some of the hand tracking examples running. None of them were working. We went back to our pass-through example. We looked at a grabbing example, looked at the different blueprints, the different nodes, see if we could export the grab component blueprint into this pass-through scene, but we cannot. And yeah, that's what we got. We also fixed audio error by just removing this broken audio dependency. But yeah, that's what we got for now. Thanks for listening and have a great week.